So today we're going to be talking about sequences. Just so you know, today it's all about the patterns. It's all about the patterns. All right. So this first example, I don't want you to write it down. I just want to see, can we recognize some of these patterns? You ready? All right. So our first vocabulary word today is arithmetic. Arithmetic. So a couple of arithmetic sequences I want to show you. So the first one goes 1, 2, 3, 4, 5, 6, 7. How would I get that next number?
8.
It's 8. How did I get it?
Add 1.
Add 1. That's it. It adds 1 to each step, right? What about, excuse me. I got 2, 5, 8, 11, 14, 7. It's adding 3.
Yep.
That's it. Adds 3 to each step. And the last one subtracts 5. So I've got 31, 26, 21, 16, 11. It's subtracting 5. I have to agree. Subtracts 5 from each step. All right. This is what I want you to write down. Arithmetic sequences have a common difference. So there in your notes for arithmetic, I want you to define that as sequences that have a common difference. One way to see these, another vocabulary word for these, is they are linear. They're linear because every step they either grow or decrease at the same rate, right? So should have written this down already. I'm about to move on.
Oh, this?
Mm-hmm.
Oh.
All right. So same examples from before. We said that first sequence 1, 2, 3, 4, 5 increased by 1, right? So what I can do is I can take that second term minus the first term. 2 minus 1 is 1. So my common difference is 1. And you can do that with any two consecutive terms. For example, 5 minus 4 also equals 1, right? What about the second one?
3.
It was 3, right? Here we had 5 minus 2 is 3. I could do that with any two consecutive terms, right? So, for example, 17 minus 14 gives you 3, right? What about that last one? We said it was negative 5 because 26 minus 31 was negative 5. I could do that with any two consecutive terms, right? 21 minus 26 is negative 5. So that's why the common difference is negative 5. So far, so good? So if it's arithmetic, it has a common difference.
It's arithmetic, not arithmetic.
Yes, it's pronounced arithmetic.
Arithmetic is probably a whole other thing.
Mm-hmm.
Oh, that's spelled
Mm-hmm. This one's pronounced arithmetic. I've heard people pronounce it differently. I've always said it arithmetic.
Arthritis.
All right, let's take a look, you guys. The next one is geometric. That's the two types of sequences we're going to talk about. Arithmetic and So here, some geometric sequences. So what's happening here? I got 1, 2, 4, 8, 16, 32. What's happening?
They're multiplying by 2.
We're multiplying by 2. 1 times 2 is
2.
1 times 2. 2 times 2 is
4.
4 times 2 is
8.
8 times 2 is
16.
16 times 2 is
32.
makes sense. Yep. So we multiply by 2 each step, right? What about this one? 81, 27, 9, 3, 1, 1/3. What's happening?
I think they're going by. Oh, no, they're not. I was going to say 54.
So are the numbers getting bigger or smaller?
Smaller.
So are we multiplying or dividing?
Dividing.
Dividing. Dividing by what? 3. 81 divided by 3 is 27. 27, check your calculator. 27 divided by 3 is 9. 9 divided by 3 is 3. 1 divided by 3 is?
Okay. Dang, that's like a big
Mm-hmm.
difference.
So is this a linear? No, it's getting closer and closer and closer together with every iteration, right?
Yeah.
The numbers. So it's exponential, right? Hold on. The last one is my favorite because look what's happening. I have negative, positive, negative, positive, negative, positive. We're bouncing back and forth. We're all over the place.
It's your adding, you're multiplying and you're dividing.
Are we? So let's see here. Negative 1. How do I get to 2?
-2.
Multiply by negative 2, right? From 2 to negative 4, what do I multiply by?
-2.
Negative 2. So we multiply by negative 2 at each step, right? All right. Second line of your notes, you guys. You ready? A geometric sequence has what we call a common ratio. Common ratio. And we're going to think of this as exponential. Exponential. You know what'll make you feel better? Sequences. Sequences cures what ails you. All right. So the first one. So again, I'm going to take the examples from the previous slide. You ready? How I can find that common ratio is I'm going to divide the consecutive numbers. So here in this first example, I said 2, where's the pen? 2 divided by 1 is 2. And we could have done that with any two consecutive numbers, right? So for example, I could have done 16 divided by 8. And I still get 2, right? Yes? What about the next one? What's 27 divided by 81? $27 divided by 81.
6.
Nope.
3.
3.
3.
Oh. It grouped all those. Oops. That's okay. Finally, 2 divided by negative 1. It's negative 2, so that common ratio is negative 2, yes?
Yeah.
All right. So let's do some patterns of our own. Let's take a look at example number 1. Example number 1, there we go. So it says create a table that describes this pattern below. And is this pattern arithmetic or geometric?
I like those triangles. They look cool.
Hey, thank you. So I shaded them in for you a little bit. So let's make a table. I'm going to draw a table right underneath. Let's call the X row the step. Because how many steps do we have? 1, 2, 3 steps shown here, right? Yes? You all agree? Yes. The table? Yes. And then the Y values, the output, is going to be the number of unshaded triangles. There we go. So, in the first step, how many unshaded triangles do we have? 1, 2, 3, 800. And the second step? 9?
8.
9. It's 9. What about the third step? 27. So question. How are the number of unshaded triangles increasing? You're trying to draw the next one?
They're getting smaller.
They're getting smaller, but the number is getting
Multiplying
bigger. So we're multiplying by what?
by 3.
By 3. Multiplying by 3, right? So would this be arithmetic or geometric?
Arithmetic.
Which one multiplies?
Geometric.
Geometric.
The ratio.
Exactly. So we have a common ratio. So I'm going to say my common ratio R is, what was my common ratio?
Times 3.
Times 3. Yes? So it's geometric. My common ratio is 3. All right. You all ready for example 2? You ready? All right. Let's take a look. Example 2. Let me scoot this on down. There we go. Example 2. It says create a table that describes the pattern below. And is the pattern arithmetic or geometric? So I'm going to create a table first. So let's make the top column the type. See, it says type there underneath each step, right? So I'm going to call it the type. So how many types do I have, Lena? 4. Beautiful, 4. And then the next column, let's count the number of squares. All right. So how many squares are in type 1? 1. How many squares are in type 2? How many squares are in type 3? 9. 9. I got your joke. What about the last one? 16. So how are these increasing?
3. No.
Times 3?
Times 2.
Times 2? 1 times 2 is 4?
Oh, times 2. Times 4.
Times 4. So 4 times 4 is 9?
But look,
Well,
2 times 2 equals 4, and 3 times 2 equals 9, 4 times 2.
so 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. Very good observation.
1 equals 1.
1 times 1 is 1, right?
Jules, don't-
So we have a relationship. We have a relationship this way, yes? Do we have a relationship this way?
Yes.
Not arithmetic, because it doesn't add by the same number. And not geometric, because it doesn't multiply by the same number, right? So we're going to say that it's neither. It's not arithmetic nor geometric. So my answer would be neither. Okay? One more example. You ready? Example 3. Example 3 says create a table that describes the pattern below. I want to know, is the pattern arithmetic or geometric? Jules, you ready?
Yes.
So let's create a table here. So let's count the steps and the number of matchsticks. All right, so how many steps do I have this time?
1, 2, 3.
3. 1, 2, 3. All right. So in the first step, how many matchsticks are there? 6. In the second step, how many matchsticks are there? 6, 7, 8, 9, 10. I count 11. 11. What about the third step?
How is it 11? Yeah, how is it 11?
Yeah,
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
What? And here's 1, 2, 3.
Oh, we got like.
2, 3, 4, 5, 6, 7, 8, 9, 10,
16.
11, 12, 13, 14, 15, 16.
I thought 16.
16.
On the last one.
Plus 5.
We're adding 5 each step, right? So if we're adding 5 each step, does that make it arithmetic or geometric? Arithmetic. And then what's my common difference?
5.
5.
This 5.
It's a positive 5. You got it.